In the previous lecture, we talked about estimation, okay? That we found the interval of the estimation in all of the topics. We now have test of hypothesis. Test of hypothesis here, we have two hypotheses, H naught and H naught. Generally, in this chapter, we talk about test of hypothesis. We have H naught, H1. H naught is something about mean, about variance, about the difference of means, about the proportions, okay? And also H1 is another statement about the same thing, but these two are different. For example, in this one, if it says, let's say mu1 equals mu2, it's in the difference of two means, okay? Let's say H0 to be mu1 equals mu2, and H1 states that mu1 doesn't equal to mu2, or mu1 is greater than mu2, or mu1 is less than mu2. We have these three cases. Okay. If mu1 to be mu2, it's a statement, it's a hypothesis. We let it's true. And we also have another hypothesis. It says, let's say mu1 doesn't equal to mu2. In this chapter, we test if these two are equal or not. Okay, we have rules to test these two. If H0 is not true, we say we reject H0. Okay, but if H1 is not true, if that statement or that hypothesis that we defined in H1 is not true, we say we cannot reject H0. We always talk about H0, okay? We always talk about H0. We say if we could reject H0 or not. Here we have some topics. These are some basic things that you could read by yourselves. The procedure here, this is the procedure. We follow these 6 steps in solving questions in this chapter. First, we identify the parameter of interest. Here, it means we need to identify that if we find the hypothesis for mean, for difference of means, or for proportions, or for variances, for the difference of two proportions, and so on, for this, okay? We need to know if in our problem, we need to find the hypothesis for which of these, for mean, for difference of means, for variance, for difference of proportions, and so on, okay? We need to identify this, identify the parameter of interest. Then we formulate the null hypothesis and alternative hypothesis. Both should be obtained from the context. Both hypotheses, H0 and H1. H0 is called hypothesis. H1 is called the alternative hypothesis. If H0 is not true, so H1 is an alternative hypothesis. Then we choose significance level. This is always given in the example or in the question. Alpha must be given in the question. Then determine the distribution and state the rejection region of the test statistic. It's different from a topic to another topic, in which interval H0 is rejected and H1 in which interval H0 is not rejected. Okay, we will study these. Then specify an appropriate test statistic. Here, for some of topics we use t-test, for some of them we use z distribution, okay, and for some of them we use chi-squared. And then finally, we decide whether reject H naught or fail to reject H naught. Means we cannot reject H naught. Here, for example, let's say in any of them, we need to find z-test. Z-test is a rule. The rule should be given during exams. Okay? The rule is going to be given in exams. Then we find z of alpha over 2. We compare these two. We say if z-test, let's say this is the statement for fail of H naught. Let z-test is less than z of alpha over 2. If we get this, we find this. We have a rule for this. And from the table, we could get this one. Okay, we have these two. We always find this one from the table and this one from the formula. The formula will be given. Okay, we compare these two. If this one is less, we say if H naught is rejected. So the alternative hypothesis is true. But if it's not true, if we don't get this inequality, if z-test is greater than z of alpha over 2, in this case, we say H naught is not rejected. We are unable to reject H naught. That means H naught is acceptable. That hypothesis that we wrote for H naught is acceptable. In the examples will be much clearer here. The first topic here is test of hypothesis for mean. It's for mean, means the first step is done. Identify the parameter of interest. We see the parameter of interest is the mean of the population. That's all about the first step. In this case, the hypothesis of the mean, we use this formula for finding z-test. Let me show you as it is given. As it will be given in the exams. These are the formulas. Look, this is Z. This is Z. Z is given. Okay? We say Z is x bar minus mu naught divided by sigma. Sigma is the standard deviation. Sigma is the standard deviation over square root of n. N is the population size. This is z-test. We say we have these three cases. The first case, in all of the topics here, we have three cases at each. For null hypothesis, we always say mu equals mu naught. Okay? This is for H naught. For H naught again, mu equals mu naught. For H naught equals mu naught. Then, based on the context, we decide which of these should we choose. Okay? Which of these should we choose? Here, H1 is that mu doesn't equal to mu naught. That's in the first case. In the second case, mu is less than mu naught, or mu is greater than mu naught. These are the defining of the alternative hypothesis. Then we say if z-test is less than minus alpha over 2, or z-test is greater than alpha over 2, we find z of alpha over 2. Z of alpha over 2. as I said, we have two hypotheses, H2 and H1. H1 is the alternative hypothesis. In the hypothesis of the mean, we always say H0 is the case that mu equals mu naught. Mu equals mu naught. And H1 is different. If mu equals mu naught, how many more cases do we have? We say mu is greater than mu naught, mu is less than mu naught, and generally mu doesn't equal. We have these three cases. In the first case, we say H1 to be mu doesn't equal mu naught. That's this is a case of an alternative hypothesis. We say we reject H0 if this is true. If this is true, we reject H0. If ZTS, we find ZTS and Z of minus alpha over 2 or Z of alpha over 2. If you find Z of alpha over 2, for obtaining minus Z of alpha over 2, just give a negative sign to it. You get it, okay? Then we say if ZTS is less than minus Z of alpha over 2, or if ZTS is greater than Z of alpha over 2, we reject H0. So H1 accepted, okay? We reject H0 and we accept H1. In the second case, if H1 to be the case that mu is less than mu naught, if this is our alternative hypothesis, we say if Z test is less than minus Z of alpha over 2, we reject H0. In this case, we reject H0. Okay? But if H1 to be, or the alternative hypothesis to be mu greater than mu naught, we say Z test, if Z test is greater than Z of alpha over 2, we reject H0. At these cases, we reject H0. If we don't get these cases, we say we are unable to reject H0 and we accept it. Okay, we accept the null hypothesis. So you should know these conditions. If you just know these conditions, it's enough. You don't need to memorize this one. Just try to recognize it from the list of formula. Okay, try to recognize from the list of formula, and the list of this list of formula will be given during exams. This list may not be in the same order. Okay, may not be in the same order. May this one to be here, this one to be there, like this. Okay. So it's important to recognize the rule in the list of formula and also memorize these conditions. At these conditions, we reject H0. This will not be true. Okay. Now we have an example here. It says mobile phones are powered by battery. The output voltage of a power supply used in a mobile phone is an important product characteristic. Specifications require at the mean output voltage must be 6. So this is the null hypothesis. It must be 6. So this is not null hypothesis. What if it is more or less? Okay. Look, let's see if it's more or less or both. I mean, it doesn't equal. Here, from this one, you could say that H0 is the case that mu is equal mu naught. This is mu naught. Mu naught is 6. For H1, we have 3 cases. We have 3 cases as it's explained here in the table. We have these three cases. The first case is mu doesn't equal to mu naught, or mu is greater than mu naught, or mu is less than mu. We have these three cases for H1. Now, we know that the standard deviation of the output voltage is sigma is given. Let's write down all the given information. Here, mu naught is 6. This is sigma. Sigma is 0.5. We decide to specify a type 1 error probability or significance level. Look, as I said before, the significance level must always given in the example. So alpha is 0.05. A random sample of n to be 20, n is given, n is 20. Is collected and obtain the sample mean output. This is sample mean, means x bar. X bar is 6.80. What conclusions should we draw? About what? About the mu naught that's given at the beginning. It says it must be 6. Mu naught must be 6, mean the mean must be 6. So the alternative hypothesis in this example is that if it's not 6, means if mu doesn't equal to mu naught. This is the null hypothesis. Okay? Later on, we have some examples that mu is greater than mu naught, or mu is less than mu naught. We have these cases also. But in this example, we say the alternative hypothesis is that mu doesn't equal to 6. Later, mu bo is not bo null hypothesis ka على mu أبي شجبت. يقولوا بو alternative كمان. أجوانا بو تشكل اسمها. قولوا تلو بسكتير اسمها. قولوا تلو بسكتير كلا ينقل يكسرنا. We take this one. Okay. So now H1 is mu doesn't equal to mu naught is 6. These are the null hypotheses. Look, this is the level of significance. This is mu naught, this is 6, I mean sigma, and this is the sample mean, and this is n. We have given these information. Now, we need to follow the 6 steps that we talked about above. First, we need to identify the parameter of interest. Means, here, we just say the parameter of interest is the mean. Only that. It's the mean, because we talk about mu. Okay? Mean of the population. Here, mu means mean. We say the parameter of interest is the population mean. That's all. You just need to write down this. Identify which topic is this example. Okay? This example is about the hypothesis of the mean. So in the first step, you say the parameter of interest is the population mean. That's all. But if you have the difference of two populations, of the mean of two populations, later on you will study, we say the parameter of interest is the population's means. We have two means in that case, mu1 minus mu2. So we have the difference of population means. We say that that's the parameter of interest. For the variance, we say that in the case of the null hypothesis is about variance, we say the parameter of interest is the variance of the population. Okay, even for the proportions. That's all. So now, in the first step, we say we just decide which topic is that example belong to. This example belongs to the population mean. Okay, here, this is hypothesis for the mean. Means the parameter of interest is the population mean. That's it. Then in the second step, we state the hypothesis. We have two hypotheses: null hypothesis, null hypothesis, and alternative hypothesis, which are H0 and H1. What's H0? H0 is the case that here is given. It says it must be 6. So H0 is that, we write down like this. H0 is that mu is equal to 6 volt. This is H0. And the alternative hypothesis, H1, is that mu doesn't equal to 6. These are the hypothesis. It is the second step. Second step يكو دو سيو تشواريش راسه خل هنا كود اسمه لقيت أنا دانامي معلومات كان هيك ترمية. Step يصير significance level الفاعل هو إيه هذا برسالة أي نسينه. That's in the fourth step. ليرة تنها ستيبي بينج calculation. تنها أمل ستيبي شوار هميشة التابل ده هميشة. Okay, we always get the result of step 4 from the tables. And in step 5, we use the formula of Z test, the test statistic. We calculate this one, and that's it. Then we compare step 4 and 5. If it satisfies these or not. If it satisfies these, we reject H0. If not, we are unable to reject H0. Here, the null hypothesis and alternative hypothesis are H0 is this versus H1 is this one. These are H0 and H1. And then in the third step, we just write down the significance level. And it must be given in the example. It's given that alpha is 0.05. Then in the fourth step, we find this one. We find this Z of alpha over 2 minus Z of alpha over 2 or Z of alpha over 2. You could find any of these. Okay? You could find any of these. Here, this means minus Z of alpha over 2 and Z of alpha over 2 in an interval. This is an interval. Okay? If Z test is not in this interval, we reject H0. If it's in the if it's in the interval, we don't reject H0. Here we say if Z test, let's draw it on the line. Here minus Z of alpha over 2 and Z of alpha over 2. This is our interval. We say if Z test is less than this, if it's here, or if it's there, that means if it's not in the interval, we reject H0. What if it is in the interval? We are unable to reject H0. Okay? And in this case, if it's less than, we reject H0. If it's greater, we don't. In this case, if it's greater, we reject H0. But if it's less, we don't. Now, let's write down everything here. It's so easy. And all the other topics are the same. All are the same. There is no difference between this topic and the difference of means. And also difference of proportions. All are the same. But it's important to recognize which topic is. Okay, only this formula is going to be changed. Only this one. Only this one is changed. Nothing else. Even here, it would be a z-test or a chi-square test or t-test or f-test. That will be changed. Now, for this example, let's write down all the solution here. That's it. The first step, we said we just write down the parameter of interest. The parameter of interest here is mean. It says the mean of the output voltage must be 6. So we define the null hypothesis, which is not by mu to be this one. What's this? It's mean. That means the parameter of interest is population mean. The parameter of interest is population mean. You just write down this. Then, in the second step, we define the hypothesis, null hypothesis, and the alternative hypothesis. This is the null hypothesis. If it satisfies this, it's null hypothesis. So null hypothesis is defined by mu equals 6. It says it must be 6. So in second step, we say H1, H naught is 6. Mu equals 6. And H1 is H1 is mu, it doesn't equal to 6. Okay, that's true. Now, in third step, we just write down the significance level. The significance level is given. It's given that alpha is 0.05. This is the significance level. So in step 3, we say alpha is 0.05. That's 3 steps. Then in step 4, we return to the table. What should you find here? We look at the last column in the table. We look at this. So here we have z of alpha over 2. In this case, we have z of alpha over 2 and minus z of alpha over 2. And we need to find that interval. Okay? We need to find this interval. Let's find z of alpha over 2. In step 4, we say we need to find z of alpha over 2. This equals. Let's return to the table. We need to use the table. Z of alpha over 2, we get from this small table, the last one in the list of tables. We say if alpha to be 0.05, Z of alpha over 2 is 1.96. We have given that alpha is 0.05. And we need to find Z of alpha over 2. So Z of alpha over 2 is 1.96. It is 1.96. How about Z of minus alpha over 2? Sorry. Minus Z of alpha over 2. It is, we just give a negative sign to the previous one. It's minus 1.96. We now have this interval minus 1.96 and 1.96. And in the next step, in step 5, What's the main step? In this step, we need to test the statistics. We need to find the z-test. We need to find the z-test. After finding z-test, we compare it with this, if it's in this interval or not. If it's in the interval, we say we cannot reject H0. But if it's not in the interval, if it is greater than 1.96 or less than minus 1.96, as it's given here. In this case, if z-test is less than minus 1.96 or z is greater than 1.96, in this example, z of alpha over 2 is 1.96. In another example, it may be changed. Okay? We say in these two cases, we reject H0. We reject H0. So it must not be 6. We say if we reject H0, return to the example. It says mu naught is 6. Okay? So mu must not be 6 if you reject that hypothesis. H0 is that mu is 6. What if you reject this? It may not be 6. It may be greater or less than 6. Now, let's find the Z statistic. We say Z in step 5, Z test is X bar minus mu naught. Mu naught is that mu is given, or minus mu. Mu is that mu naught which is given. Mu is the mu naught. Okay? Dividing by, this is dividing by sigma over square root of n. This is the rule. As I said, the rules are given in the list of formulas, but it's important that you recognize which one is. It's not written in the list of formulas. This rule is for that topic and this is for that topic, but you should recognize it. Look here, you should know for the mean, we have this or that, both are the same. Here, if the standard deviation is given, here this if the variance is given, we take its square root. Both are the same. Now we find the z-test. We said it's X bar minus mu over sigma over square root of n. All of these are given. Mu naught is given, which is mu. X bar is given. Sigma is given. And n is given. All are given. Calculate this. What you get? Let me write down the result here. It's 7.16. It is 7.16. Now we compare this with the previous step. We said it's given in the table that if this value exceeds this interval, we reject H0. But if it is in this interval, we are unable to reject H0. What's this? And this is 7.16. And this is from minus 1.96 to 1.96. Is this value in this interval or not? It's not. We say since it's in step 6, which is the last step. Since z-test is 7.16 is greater than 1.996, which is z of alpha over 2, means z-test exceeds the interval. So we reject H0. We reject H0 in that case. We said if it is greater than z of alpha over 2, or if it is less than minus z of alpha over 2, In these two cases, this is the rejection region. We reject H0 and we accept H1. So what's the conclusion here? Which is, since Z test is greater than Z of alpha over 2, we reject H0 and mu doesn't equal to what? To 6. We choose H1, okay? So the mean might not be 6. It might be greater or less than 6. That's all. زول أسهل. ستيب هي كم ودوم سيم شوارع تنهال معلومات وتيبلا كود اسمعنا كده. ستيب بينجم كالكوليشن كيك. ستيب يشجم براود دي ستيب شوارع بينجم. هيك يترمي. بلا. سي أوكا براود معنا كل قال ناقصك وين نو الشاشة كده. شو كتير لو بلا هالرجع. أوكي. We say we are unable to reject the null hypothesis. Okay? We will have some examples like that later on. You will study this. Now, we say if the variance is unknown, it's given in the example that variance is unknown. And also, to find the test of hypothesis for the mean, we use the same thing. It's the same rule as we used before in the previous example. But instead of having sigma here, we have standard deviation. It's the same. It's the same rule. But in this case, we use t-test. In this case, we use t-test. Look, if the variance is not given for finding the hypothesis of the mean, if the parameter of interest is the population mean, and the variance is not given, we say we need to use t-test. We say t-test is this one. Step 1, 2, 3, 4 are all the same. But in step 4, we used Z of alpha over 2. But now we use T of alpha over 2 and N minus 1. And also T of alpha over 2 and N minus 1. If TTS is less than minus T of alpha over 2 and N minus 1, or if TTS is greater than T of alpha over 2 and N minus 1, in these two cases, we reject H0. H0 states that mu equals mu naught. If not, if it's between them, we say we don't reject H0 and we choose H0. H0 is true. But if we reject H0, we choose H1. And these are the same as above. Let's take this example. Let's see. Look, it says referring to example 1. Back to example 1. Suppose that true variance is unknown. It's given. The variance is unknown. So it's this case. We need to use t-test. We need to use the t-test case. It's the second case. Then, so 10 determinations of the output voltage of power supply yielded the following values. These are the output voltage. We have 10, okay? The rule is, we say t-test is x bar minus mu naught over s over square root of n. We need to have x bar, mu naught, s, and square root of n. It says, can we say that the average output voltage mu equal to 6. So this is the null hypothesis. The alternative hypothesis is doesn't equal to 6. H naught is that mu is this one. H1 is mu doesn't equal to 6. Okay, these are H0 and H1. From the context, you could get what's H0 and what's H1. Now, from these data, we could get X bar, sigma, and N. This is mu. This is mu. It's given. Mu naught. Yeah, mu naught is 6. How about N? N is the number of data. It's 10. It's number of samples. It's 10, sorry. Then, what are X bar and S? X bar is the sum of these data dividing by 10. It is 6.05 plus 6.06 plus 6.03 up to 6.03, the last one. We sum these all dividing by the number of data, which is 10, dividing by 10, and I'm just going to write down the result here. X bar is 6.014. It is 6.014. كوي هم جمارة كان دابش جمارة كان ددا. Then we need to find S. S is the square root of sigma squared. Okay, it's the square root of variance. We need to find the variance, but this variance is not the true variance, as it's given that the true variance is unknown. Okay, we use that case in which the variance is not given. We say S is, let me write down sigma squared. Sigma squared is, we find x1 minus x bar squared plus x2 minus x bar squared plus all. Okay, what are x1 and x2? This is x1. This minus x bar, we already found x bar in the previous step. Then this one minus x bar and then squared. And this one minus x bar squared. This one minus x bar squared. This one minus x bar squared. This one, let me write down. Here, sigma squared is x1. This is x1. This is x2 up to x10. Sigma squared is x1 minus x bar squared. X bar is 6.014. It's the sum of all numbers divided by the number of numbers, plus x2 minus x bar squared plus x3 minus x bar squared plus up to x10 minus x bar squared, all divided by n. We find this. Okay, and then S is the square root of this. We just take the square root for the results. We get S. From the data, we could get S. We obtained S also. Let me see what's the result here. S is 0.0353. 0.0353. This is S. This is the standard deviation. We just have these four things for finding the test statistic or t-test. At step 5. Then we compare step 4 and 5. If they satisfy these conditions or not. If they satisfy these conditions, we reject it. If not, we don't reject it. Let's solve it here. In the first one, the parameter of interest is the population mean. And then the null hypothesis and alternative hypothesis are, this is not equal. Okay, this is not equal. In step 3, we just write down the significance. We write down the significance level. Then we say we reject H naught if t test is less than this, or t test is greater than t of alpha over 2 and n minus 1. In these two cases, we reject it because we choose the case that H1 is mu doesn't equal to mu naught. If mu doesn't equal to mu naught, we have these two cases. If t test is less than minus t of alpha over 2 and n minus 1, or if t test is greater than t of alpha over 2 and n minus 1, in these cases, we reject H. This is step 4. We find t of minus alpha over 2 and n minus 1, and also t of alpha over 2 and n minus 1. Let's return to the table. Alpha over 2 is, alpha is 0.05, and alpha over 2 is 0.025. Okay? Now, we are going to look for 0.025 and t of 0.025 and n minus 1. N is 10, as you have 10 data. Minus 1 is 9. We look for this in the table. Let's find t tables. This is t table. T of alpha and v. Alpha is the horizontal one, and v is the vertical one. We have t of 0.025 and 9. Let's find 0.025 first. This one is. It's 0.025. Then vertically, we look for 9. This is 9. This is 0.025 and 9. And this is the t of alpha over 2 and n minus 1. It's step 4. In step 4, we always use the tables. Always given, or it's always given. Okay? It's the significance level. It's always given. So now we have 2.262. This is step 4. This is for t of alpha over 2. T of alpha over 2. If it's minus t of alpha over 2 and 9 is minus 2.62. And for the positive one is 2.62. We say if t test, we now in step 5, we use this formula. We use this formula. We calculate this. And then we come in step 6, we compare step 4 and 5. In step 4, we obtain from the table. In step 5, we obtain the calculation from the calculation of this formula. We compare these two. We say if t test is less than this, or t test is greater than this, we reject H naught. What if these two conditions not hold? We say we are unable to reject H naught. This is t test. In step 5, we just calculate this. We found these, or we have these all information. We just put their values here and we get 1.254. We set t of alpha over 2 and n minus 1 is 2.262. Is it? Yes. What if it is negative? Minus t of alpha over 2 and n minus 1 is minus 2.262. In this case, let's write down the interval. The interval is minus 2.262 to 2.262. Is this value in that interval? Yes, it's in that interval. It's because it's 1.254. It's between these two values. So in this case, we say we are unable to reject H because we said if it is greater than this value or less than this value, in these two cases, we reject H. What if this in the interval? We say we are unable to reject H naught. Look at the table. In the table, we have that. If t-test is less than this value or t-test is greater than this value, we reject H naught. But none of these obtained here. In that example, none of those two conditions obtained. So we say, since the value of this one is between these two, we are unable to reject H naught. Okay, and there is no strong evidence to the output equal to 6. That's okay. Okay, let's take a break for 10 minutes. We now have test of hypothesis for the variance. The previous one was for the mean. Test of hypothesis for the mean. We now have test of hypothesis for the variance. These calculations or this derivation of the rules are not required from you. Only these tables. Okay, and this rule is going to be given during exams. You could find this in the list of formulas. Look, this one is chi-squared is this one. N minus 1 s squared over sigma naught squared. Where is chi-squared? That's it. This is the rule. Okay? So now, in this case, we use chi-squared table. In this case, we use chi-squared table. We don't use t-table or z-table. We use chi-squared table. Where's chi-squared table? This t, this chi-squared. This is chi-squared table. We use this table. That's it. Here, we say the null hypothesis is sigma squared equals sigma naught squared. Means variance equals to the given variance. If it's equal. The alternative one doesn't equal. So we say it's rejected if chi-square test, this one chi-square test. This is chi-square test, this formula. It's step 5. If it's less than this one, this is step 4 that you could get from the table. Or chi-square test is greater than this one, we say it's rejected. Which of the hypotheses rejected? H naught. We always reject H naught or the null hypothesis if this condition satisfied. But if H naught to be this one and the alternative hypothesis to be sigma squared is less than sigma naught squared, if we have the case that the variance is less than the given variance. If we have that case, we say if chi-squared test is less than chi-squared of 1 minus alpha and n minus 1, If it's less than, if chi-squared is less than that, chi-squared, I mean chi-squared of 1 minus alpha and n minus 1. If it satisfies this, I mean step 4 and 5 satisfies this one, we say H naught is rejected. If not, we say H naught is not rejected. But if we choose H1 to be sigma squared to be greater than H naught, sigma naught squared, we say if chi-squared test of alpha and n minus 1, in the above one we had alpha of 1 minus chi-squared of 1 minus alpha and n minus 1. But here we have chi-squared of alpha and n minus 1. If chi-squared test is greater than this, we say we reject H naught. If not, we accept H naught, or we are unable to reject H naught. So it's important to recognize the question and to know which rule do you use. Here we use chi-squared. In the list of formulas, we look for chi-squared. We don't look for Z or T or F or anything. Now, we have an example. It says a drilling machine is used to drill metal plates used in batteries. A random sample of 25 plates result in simple variance hole. Look, this is the variance. Is 1.82. Now, we say N is given. It's the sample size. N is 25. Variance is 1.82. If the variance of hole diameter exceeds 1, so if this one, we say if it exceeds 1, the drilling machine must be serviced. Now, the null hypothesis is that if the diameter if the diameter variance is 1, this is H naught. It's always equal. H naught is always equal to the given mean, to the given variance, and anything. Okay? It says if it exceeds, it's more than this. Exceeds means more than this. It's the it's the alternative hypothesis. We say the null hypothesis is that sigma squared is equal to 1. And the alternative hypothesis is that if it exceeds 1, if it exceeds 1, so we say sigma squared is greater than 1. So it is the third case. We don't use the first one. We use the third one. Based on the context, you know which case is that. It's this case. But if it says that if the variance hole is not 1, it needs to be serviced. If it's not 1, means it's both cases. It's greater or less. So it's the first case. It's the first case. But if it says the variance of hole diameter is less than 1, it needs to be serviced. In this case, we use the second one because it says less than. In this example, it's given that if the variance hole diameter exceeds 1, it needs to be serviced. That means if the variance exceeds 1, it needs to be serviced. So we say if the variance is greater than 1, it needs to be serviced. This is the alternative hypothesis. If it's 1, it doesn't need to be serviced. So this is the null hypothesis in the case if sigma squared equals 1. And the alternative one, which is H1, is that if sigma squared is greater than 1. Is there evidence that the machine needs to be serviced. عليه هيك بلقي هي بوي كأما شنو بيشتي بد هين بيت بس سيرفيس بيت بتشاكر نو بيت ليش حاول تلقى بيش بتشاكر نو أجل زي ما سكول قولت كاتو إنهم هاي بتستك It depends on variance. It depends on variance. I mean the surface of the machine depends on its variance. If it's 1, it doesn't need. If it's greater, we need to service the machine. Use alpha to be 0.01 and assume that the whole diameter has normal distributions. Now, in the first step, we need to write down the parameter of interest. The parameter of interest is what? Is the variance. The variance is the population variance. That's it. It's the variance. In the previous one, we said it's mean, population mean. Now we have variance. It depends on the variance. So the parameter of interest is variance. In the second step, we write down the hypothesis, null hypothesis, and the alternative hypothesis. We say the null hypothesis and alternative hypothesis are H naught is sigma squared equals 1. And H1 is sigma squared is greater than 1. Then it's the second step. In step 3, we just write down the significance level. What's the significance level? It's alpha. It's the value of alpha. So alpha is 0.01. That's third step. In the fourth step, we calculate the value of alpha over 2 and n minus 1 from the table. Which table? Chi-square table. In step 4, we always use the tables. In this case, as its variance, we need to use chi-squared. Look, we need to use chi-squared. Which case is that? This one is. That's this one. We need to find chi-squared of alpha and n minus 1. We need to find alpha and n minus 1. What if it is the previous case? In this case, we find chi-squared of 1 minus alpha and n minus 1. Okay? It's 1 minus alpha, and these two have different values. Because for this one, as alpha is 0.01, let's say it's alpha to be 0.01. For this one, it's chi-squared of 0.01 and n minus 1. N is 25 in this example. It's 24. This is different from if we have this case, we say chi-squared is 1 minus alpha. 1 minus alpha is 1 minus 0.01, which is 0.99. And 24. These two have different values. Okay? Be careful with that. Here we have this case. This one. We need to find chi-squared of alpha and n minus 1. And we reject if this is greater than that value. Based on the table, we say if chi-squared test is greater than this one, we reject. But here we need to find this one. What's chi-squared of 0.01 and 24? We return to the table. 0.01, this is 0.01. And 24. 24. It is 42.98. It is 42.98. That's it. It's step 4. Then in step 5, we calculate this. All are given. All are given. This is squared is 1.82. We have that. And sigma naught is 1. Okay, sigma naught is 1. This is given. This is given. And this is 25. We just calculate. Okay, we just calculate. It is sigma naught squared. Sigma naught squared is 1. S squared is 1.82. And n is 25. Multiply these and divide. You get the result is 43.68. This is chi-square test. In step 5 is 43.68. This is step 5. In step 4, we obtain that this is 42.98. It's from the table. And this is calculation. Compare these two. Which one is bigger? Chi-square test is bigger than this one. It's bigger than that value. Return to the table. If it is bigger, if chi-square test is bigger than chi-square of alpha and n minus 1, we reject H naught because this is the rejection region. Okay, we reject H naught. So if we reject H naught, means we accept H1. So the variance of diameter is greater than 1. And the machine needs to be serviced. We said if the variance is greater than 1, it's the hypothesis that the machine needs to be serviced. It doesn't equal to 1. Okay? As it is greater, as TTS is greater than T of alpha and n minus 1, we say the null hypothesis is rejected. This is rejected. Okay? This one is. In this case, if the variance is greater than 1, it says the drilling machine must be serviced. Okay? In step 6, we say, since this one is greater, we reject H naught. And we conclude that at this level of significance, the variance of the whole diameter exceeds this one. And therefore, the machine needs to be serviced. You need to write down this. What does it mean if this one is greater? Okay? Based on the given example, you know what does this mean? Okay, if you reject H naught, we accept H1. H1 is accepted in only the case that if the machine needs to be serviced, because the diameter variance is greater than 1. That's it. It is for the value and for the variance. Step you do. على چی step you do. على اگر diameter variance كمان يكبو هیچ کشی نیه. بلام اگر لو تیپر. بله على if على چی؟ If the variance whole diameter exceeds 1, so if it's greater than 1, the drilling machine must be serviced. So exceeds 1, we leave that to be H1. In the case if it doesn't need to be serviced, we leave that to be H naught. So in that case, if we don't need to service, Sigma squared is 1. Okay, it's h0. What if it exceeds? It's h1. باشا أقل لي يكتب قري أما دانين با alternative hypothesis second بالي h1 أي خوي تشيا h0 بالي أقل خوي بقى يكسان بو هميشي يكسانه بكاره إن h0. Okay, but for h1 it could be greater, less, or not equal. We have these three cases for h1. But in this case, we say it must be greater because it exceeds. In step 4, we find, look, based on this one, we have null hypothesis, sigma squared equals sigma naught. And the alternative hypothesis is that sigma squared is greater than sigma naught squared. Return to the table. Based on the table, we decide which one is. It's the third case. Okay? تنها h1 وبريالين كام كيس يعني چونکه h نوتك همیشه یکسان هم یکسان. Okay? h1 we choose that sigma squared is greater than 1. That one is sigma naught squared. If we have this, in step 4, we need to find this one. We need to find this. It is sigma squared, chi squared of alpha and n minus 1. N is noun, alpha is noun. It is chi squared of alpha is 0.0 and n minus 1 is 25. 25 minus 1 is 24. Okay? Look for these two values in chi-squared table. This is the table of chi-squared. That's it. This is chi-squared table. Okay? We look for 0.01 horizontally and vertically 24. This is 0.01. Up to down to 24. This is 24. This one is. Okay? It's 42.90. It's step 4. And then in step 5, we calculate, we compare them. If chi-square test, which that we calculated in step 5, if it's greater than this one, we reject it. If not, we accept it. سيكا شوار لا تقبلوا دسمان. Pinch calculation. شش outcome okay, conclusion okay. Reject again. وقت بس calculation بس recognize your طريقة كان هيك يعني. We now have test of hypothesis for the difference between the means. In the difference of two means, we have two populations. We have two means. We have two variances. We have anything that we need. Okay? Here, it's calculations. That ones. We say testing mu1 minus mu2 when variance are noun. If the variances are noun, here we have two cases. If the variances are noun or if the variances are unknown. It's given in the example that the variances are noun, the variances are noun, or the variances are unknown. If the variances are noun, I mean variance for the first population and for the second population are given. We use test statistic in this formula. We use this formula for test statistics. You could find this in the list of formulas. This one is, you could say this one. Or this one, sorry, this one is, it's normal distribution. This one is, okay? This is if the variances are noun. And this is for the case if the variances are unknown. Only sigma squared changed to S squared, standard deviation squared. Look, only these two are changed. It's given in the list of formulas. Now, we say, for the difference of two means, we say if their difference is, let's say, 10, okay? That means mu1 minus mu2 is 10. This is null hypothesis. For the alternative hypothesis, we have three cases always. We have three cases, but we need to choose one of them based on the context, based on the example. We say mu1 minus mu2 doesn't equal to 10, or mu1 minus mu2 is greater than 10, or mu1 minus mu2 is less than 10. We have these three cases for the alternative hypothesis. And here, for the first case, we say if the z-test, here we use z-test. We use z-test, that one is. This is z-test. If it is less than minus z of alpha over 2, we use z-table. Or it's greater than z of alpha over 2, we reject agents. But if it is this case, this is mu naught. This is mu naught. Okay? This is mu naught. And this is mu naught. If H1 to be mu1 minus mu2 is less than mu naught is that value that I have written down. It's the difference of their means. If z-test is less than minus z of alpha over 2, this is over 2. Over 2. We have over 2 there. Okay? If z-test is less than minus z of alpha over 2, we reject H. If not, we are unable to reject H. We don't talk about H1. We don't say we accept H1 or something like this. Okay? And then, if in the last case, if z-test is greater than z of alpha over 2, we reject H0. If not, we accept H0. You now have an example. There is no examples to be solved here. Okay, do this one by ourselves. Okay, it's easy. Just do it by ourselves. If you couldn't, let me know. Okay, we will have similar examples to this one in the next case. In the next case, we have similar example. If the variance is unknown, if the variance is unknown. In the first case, as you said, for the difference of two means, we have two cases. Test hypothesis for the difference of two means, we have two cases. If the variance unknown, sorry, noun, or if the variance unknown, okay, the variance for both populations now, it's the first case. If the variance for both populations are unknown, that's the second case. For this one, for the second case, if the variance are unknown, we use this rule. Okay. Here, this is level of freedom. Degree of freedom, sorry. This degree of freedom. Degree of freedom is N1 plus N2 minus 2. You should know that. Degree of freedom is N1 plus N2 minus 2. Check which rule is this one. X1 notion, that one. These are both the same. This one is. Okay? It's T. Look, the degree of freedom is given here. Okay? Even the degree of freedom is given. In T table, we need degree of freedom. It's N1 plus N2 minus 2. N1 and N2 are the population sizes. Minus 2. It's similar to the previous ones. But here we have t-tests. You should know this is t-test. Here we use t-test. Even based on the rule, you know that's t-test. Okay? Based on the rule, you know that's t-test as it's t. But all what's in, even here, it says t is equal to this one. So it's t-test. Z equals to this one. Here we use z-test. Here, for step 4, we use Z table. Even here, we use Z table. And then for this one, we use T table. So for the last one, we use chi-square table. Okay? This is the rule. We say ASP in the denominator, we have ASP. And the numerator is the same. X1 minus X2 minus mu1 minus mu2 over ASP times square root of 1 over N1 plus 1 over N2. What's ASP? ASP should be given in the list of tables. That's it. This is ASP. This is ASP. We calculate this. It's only based on the population sizes and their standard deviations. Okay, S1 and S2 should be given in the example. We just square them, put it here. N1 and N2 are the population size. It's just calculations. Look at this example. It says a researcher wants to prove that brand X size AAA battery lasts an average of at least 30 minutes longer than Y. That means here, as it's the difference between two means, we say X1 bar minus X2 bar is greater than 30. Okay? At least 30. Two normally distributed independent random samples of 10 each brand are selected. That means N1 is 10 and N2 is 10. As it says, the same sample size taken from both. N1 is 10 and N2 is 10. And the batteries are run continuously until they are no longer functioning, until they are dying. The sample mean life for brand X, it's for the first brand, is found to be X bar is 328. X1 bar is 328. And the sample standard deviation, S1, is 46. And then the results for the brand Y batteries are X bar is 472. X2 bar is 472. And S2 is 52 minutes. Is there evidence that brand X batteries last at least 30 minutes longer than brand Y batteries of the same size? Use alpha to be 0.05. This is step 3. In step 3, you just write down it. Okay? We now have two populations. And we have given N1, N2, X1 bar, X2 bar, S1 and S2. Okay? We say, Let's return to the table. H naught is M1 minus mu1 minus mu2, which is the mean of the first branch minus mean of the second branch, is equal to mu naught. Here mu naught is 30. Mu naught is 30. Okay? Mu naught is 30. So mu1 minus mu2 is 30. This is H naught. This is H naught. How about H1? H1 if it's less than 30. Okay? And this is the second step. As you have two populations, it talks about the difference of their means, talks about difference of means. So we say in the first step, the parameter of interest are mu1 and mu2. Mu1 and mu2. These are parameter of interests. Okay? Then H naught is the case that their difference is 30. And H1 is if the difference is less than 50. Now, we have alpha, which is 0.5. Then for step 4, we return to the table. We return to this table. It is this case. No, sorry, it's not that case. It's less than. It's in the case that mu1 minus mu2 is less than mu naught. This one is. In this case, we need to find T of alpha and V, and we give a negative sign to it. What's alpha? Alpha, it's given that 0.05. So we need to find T of 0.05 and V. V is level of freedom, which is N1 minus N plus N2 minus 2. N1 is 10. N2 is 10. Minus 2 is 18. Okay? Now we return to T table. In the list of tables, we look for T of 0.05 and 18. T table. This T table. This is T table. 0.05 and 18. We look for 0.05 and 18. Where is 0.05 horizontally? We look for 0.05. This one is. If it's 0.005, that one is. But in our example, it's given that alpha is 0.05. This one is. And 18. This is 0.05. Let's count it down to 18. It's 1.734. It's 1.734. In step 4, we say we need to find minus T of 0.05 and 18, which is 1.734. 1 minus 1.734. We reject, we write down, look, in step 4, we write down, reject if T test is less than T of alpha over alpha and V, which is 1.734. If it's less, it's minus, sorry. If it's less than this, we reject. If not, we accept. Then in step 5, we calculate this. In calculation of this, first we need to find SP. SP, as I talked about here, it depends on S1 squared and S2 squared. N1 and N2. That's it's just calculations left here. X1 bar, S1 bar, X2 bar, S2 bar, N1 plus N2 is 10. These all are given. First, you need to find SP. SP is this. This is SP squared. After finding SP squared, we just take its square to get SP, and then we say T test is x1 bar minus x2 bar minus x1 minus x2. Sorry, mu1 minus mu2. Mu1 and mu2 are not given, but their difference is given. It's the null hypothesis. Mu1 minus mu2 is 30. It's given that the difference is 30. Okay? Even mu1 and mu2 are not given, but the difference is 30. We write down 30 here. And we calculate. We get minus 7.9255. Is it less than minus 1.734? Yes. So we reject H naught. We reject H naught. Since T test is less than this one, we reject H naught. And we don't have an evidence. As you see in the example, it says, is the evidence that brand X batteries last at least 30 minutes longer than Y batteries at the same size. So we say there is no evidence that brand X batteries last at least 30 minutes longer than brand Y. We have no that evidence because the null hypothesis is rejected. Okay? If sigma t, if T test is greater than minus T of alpha and V, in that case, we say there is a strong evidence that brand X batteries are better. Yes. So it's كذا ليه على بلاني كمو أما باشا سي أخي ما زيادة المعنى هي زيادة لك هي بوني هي إما أنا أجر وانا وانيا ليه على شيء ليه عليه أمريكا همانا لا نكم أمنا زيادة بنت بلا إما علي باوانا بنت شي داني في سوانا كي داني نونيا لبر أوي بشكل داني باشا. So the previous example that we left, in the case if the variables are known, is similar to this one. It's similar to this one. Only the formula of step 5 has changed. We now have another case. Here, this one was about if the variances are equal, if they have similar variances, if both populations have the same variance. Okay, as we did before, as we did now, if the variance are equal is the above case, but if the variance are unequal, vale, vale. هلا سوي بيشوي سوى جواسي يعني باونتا ماشي. If this is in the case if the variance are unknown, but if the variance are not, okay. In the previous case, we said if the variances are unknown and they have the same values, they both have the same values. But here we say if the variances are unknown, but they have different variances. This is the rule. The degree of freedom is changed. This is degree of freedom. In the previous one, we said degree of freedom is n1 plus n2 minus 2. But here, this one is degree of freedom. And here, it's given. It's TV, where V is this one. This degree of freedom. It's similar, and we use T table again. These are all alpha over 2, alpha over 2. Okay? These are alpha, no, not alpha over 2. These are only alpha, but the above ones are alpha over 2. Here you have an example. It says a scientist who wants to determine how to catalyze will affect the mean yield of a chemical process. Two normally distributed independent random samples of N1 is 2 for catalyzed C1 and N2 is 10 for C2 are selected. So N1 and N2. Up to now, we have only N1 and N2. The sample mean yield catalyzed C1 is found to be this one, this X1 bar. And its standard deviation is this one. The results for the catalyzed C2 are X2 bar and S2. Up to now, we have N1, N2, X1 bar, X2 bar, sigma, S1 bar, S2 bar. Sorry, S1 and S2. We have these 6 information. Is there any evidence between the mean yield? Is there any difference between the mean yield? Look, if there is no difference, it is the null hypothesis. But if there is difference, we don't know which one is bigger. We take both cases. Okay, so the null hypothesis is that mu1 minus mu2 is 0 if there is no difference between them. But for the alternative hypothesis is that mu1 minus mu2 doesn't equal to 0. This is the alternative hypothesis. Okay. Use alpha to be 0.01 and assume that two population variances are unequal. The population variances are unequal. It's given that their variances are equal. Now, as it says, is there any difference between the mean? Means it's difference of their means. It's the case that difference of their means. Okay, so the parameter of interest are mu1 and mu2. We just write down this. In step 2, we write down the hypothesis. If there is no difference between them, we put it for H0 for the null hypothesis. And if there is difference, means they are not equal, their difference is not equal to 0. Or this one, if they are equal. And this is H1, which is the alternative hypothesis. And this is alpha to be 0.01. Then for T of, we need to find T of alpha and V. We need to find T of alpha over 2 and V. It's negative value and positive value. Alpha is given. We need to find the degree of freedom. Degree of freedom is V. V is this row. It depends on S1, S2, and N1, N2. Okay, we calculate this. S1 squared over N1 plus S2 squared over N2 and all squares. All dividing by this denominator. It's calculated here and is 18.6489. We always round it. Okay, we always round it to the nearest integer. It is approximately 19. Now we need to find T of alpha over 2 and 19. What's alpha? We found it. It is 0.01. This is 0.01. 0.01 dividing by 2 is 4.005. Okay. We need to find T of 0.005 and 19. We need to find this. then بلانسير كان ليرة لتي لكاي سكرين الفا اوفر تما هو ده بشكي بلا لزيتها عقادات زيت من 0.0 بينش لسبدو ناس متابشي مكان ولن شيب كان علم اجا الفا كم 0.0 بينش بو يكسر كاتا ان زيت الفا اوفر 2 اكاتا باشا هيس ناكل. Now we look for T of 0.005 and 19 in T table. T table is this one. 0.005 and 19. 0.005, this one is. And 19. This one is. So it's 2.8861. It's 2.861. Now we say it's 2.861. That's step 4. We say in step 4, we say reject in 4, reject. If t-test is less than minus t of alpha over 2 and v, which equals to minus 2.861, or t-test is greater than t of alpha over 2 and v, which equals to 2.861. Okay? In these two cases, we reject. If we return to the table, in these two cases, we reject. Reject what? H naught. Okay? Now, in step 5, we need to calculate that t-test. We need to calculate t-test. And just calculations, we get 0.9094. 0.9094. Comparing this with these two. We said if this, is it less than this one? No. Is it greater than this one? No. Means it doesn't satisfy any of these two conditions. It doesn't satisfy these two conditions. Means H naught is not rejected. Okay? If it satisfies any of these, we'll reject H naught. But 0.9 doesn't satisfy any of these two conditions. Means we are unable to reject H naught. We say in step 6 that is less than this one. We are failed to reject H naught, or we are unable to reject H naught. Means we conclude that there is no difference between them. We accept H naught. H naught says mu1 minus mu2 equals 0. So mu1 equals mu2. We say they have the same mean. They have the same mean. Okay? As it says, there is no difference between their mean. Means they are equal. If you have no questions, let's take a break for 10 minutes. We now have the test hypothesis. The test hypothesis for the difference between two proportions. Up to now, we studied test hypothesis for a mean, test hypothesis for variance, test hypothesis for the difference of two means. We studied these three. And we now have test of hypothesis for the difference of proportions. Here, we use this table. This is our table. It's testing pi1 minus pi2. It's denoted by pi1 and pi2. These two are proportions. We say, as you have two populations, we have pi1, pi2, we have n1, n2, okay? We say it is p1 minus p2 dividing by p of p times 1 minus p of p, all multiplying by 1 over n plus 1 over n1 plus 1 over n2. Let's look for this rule in the list of formulas. That's it. These two together. This is p of p that we use inside the square root in the denominator. Okay? First, you need to find p of p. We use this in step 5. Okay? That's the Z test. We use it in step 5. And this is, we talked about this a lot in the previous ones. We now have this example. It's important to recognize the question. Usual medication was given to a random sample of 180 patients from District A who have high fever. New medication. So now we have two types of medications, usual medication and new medication. We have these two types of medications. The usual medication is applied in the first population, in population A. And a new medication was given to random sample of 200 patients of District B. هر كان لهرمك تاعي كلاونا توا دو جور شارع سري بزيشكين داني كان يوجولك داني كان شتي تازه يوجولك لسه District A تاعي كلاونا توا أي تري أنسى District B تاعي كلاونا توا who have high fever. If 144 and 180 patients recover from the fever. Look, here it says 144 people recovered by using the usual medication in the District A. And 180 people recovered from the new medication by using the new medication in the District B. It says, is the new medication helps to cure better the fever or not? I mean, is the new medication is better or not? We say if they are equal, it's null hypothesis. If they both have the same, it's null hypothesis. If the usual medication is more worse than the newer medication, it means if the new medication is better than the usual medication, it's the alternative hypothesis. It's given. As the new medication helps to cure better fever, as the new medication is better, means the number of those people who get better from the new medication is more than the number of those people who gets better from the usual medication. This means pi2 is greater than pi1. Pi2 represents the proportion of the new medication, and pi1 is the proportion of the usual medication. Now we have sample size of 180 in District A. So N1 is 180 and N2 is 200. Then what are P1 and P2 or pi1 and pi2? So P1 is the number of those people, is the rate of getting better from fever by using the usual medication. It says it's 144 dividing by the number of population. It's the sample from all. Okay, it's case from all. The cases that get better are 144. What's the total population of the first population? It is 180. P1 is 144 over 180. أنا صوت شنو شوال كاس تصور شتاك الشاكو كواتا أنا صوت شو تصور شتاك P1 and P2 is and says 180 people recover out of 200 people. It's in the second, as it says respectively, means the first one is for the first district and the second is for the second district. Population of the first district which are taken is 180, and in the second we took 200s. 180 of them are recovered. These are P1 and P2. It says, is there an evidence to show the new medication is better? Means, is there any evidence that pi2 is greater than pi1? Pi2 means the rate of recovered people by using the new medication. And pi1 represents the rate of recovered people by using the usual medication. This is H1. H0, as we said before, it's always equality. Okay? We say H0 is if they're equal, if there's no difference between the usual and new medications. Is H is pi1 is equal to pi2, or pi1 minus pi2 equals 0. You can say pi1 minus pi2 equals 0 if they are the same. Now, in the first step, we know that it's difference of two proportions. It's difference of two proportions. As it says, is there any difference between? It says the new medication is better than the usual one. Means it's the difference of their proportions. We say first, in the first step, the parameter of interest are pi1 and pi2. They are pi1 and pi2. And in the second step, we define the hypothesis, null hypothesis, and the alternative hypothesis. Null hypothesis is the case that pi1 equals pi2. And the alternative hypothesis is the case that pi2 is greater than pi1. We talked about this. Okay? Then alpha is given at step 3. In step 4, look, in step 4, we need to find z of alpha over 2. This is alpha over 2. This is alpha over 2. It must be alpha over 2. Okay? Z of alpha over 2. Let's find it. What's alpha? Alpha is given. Alpha is 0.05. So we need to find z of 0.05 over 2. Let's return to the table. Z table. It's this little table at the end of the list of tables. Z of 0.05. What's it? If Z to be 0.05, Z of alpha over 2 is 1.96. We take this. It is 1.96. How about minus Z of alpha over 2? It's minus 1.96. We say pi1 here, it means pi1 minus pi2 is less than 0, is it? Moving this to the other side, we get pi1 minus pi2 is less than 0. Which case is pi1 minus pi2 is less than 0. So we use this one. We found minus z of alpha over 2 is minus 1.96, is it? Yes. At step 1, we reject if z test is less than this. You say in step 4, we say reject if Z test is less than minus Z of alpha over 2, which is minus 1.96. Okay. Now, we find it. Oh, it's Z alpha. Not Z, sorry, it's Z of alpha. No, it's not Z of alpha over 2. It's only Z alpha. Okay? It's only Z alpha, not alpha over 2 for this case. Alpha here is 0.05. What is 2 times alpha? It's 0.1. We say we need to find Z of 0.1 over 2. We say if we have alpha over 2 like this, it is 0.1. It is 1.645. Okay? It is 1. إما هميشه أبي زد alpha over 2 معناها. بلان دير alpha معه. داوش دوماني. كاتبه fraction دروس كم شركة دو بيت. ضربي دويك. كزربي دومان كداوش دوش يكي. fraction كمان نسبة. Okay? So it is 1.645. Z of alpha is minus Z of alpha is, sorry. It is minus 1.645. This is step 4. In step 5, we calculate this. But here, PP is obtained by this one. What are X1, capital X1 and capital X2? Capital X1 is here at 180. It's the number of population of the first district. And this one is 200. But N1 is the number of those people which are recovered from the first population, which is 144. And this one is the number of population which are recovered from the second population, which is 180. That's it. Find this one, PP, and plug it to this rule, and you already have little n1 and little n2, p1, p2, you found these two. So here, this could be x1, x2, and little n1 is 144. Little n2 is 180. These are little n1 and little n2. And then we could calculate and we get this value. Is this less than minus Z of alpha over 2? This is minus, sorry, that one is not. This one is minus 1.645. Is this less than minus 1.645? Yes, it's minus 2.4, 2.7. It's less than, means we reject the null hypothesis. We reject it, means they are not equal. They are not equally recover people from fever. Means the new medication is better. Means then the second hypothesis accepted. So we say the new medication is better. Okay. بله باش تو بلام ابي تو calculation هربكي ابي ام calculation هربكي ليه شي معناها the test hypothesis for the ratio of two of variances here we use this rule. We use F distribution. Okay, means we use F table in step 4. Okay, we have S1 squared over S2 squared. We just have this in the form. Okay, not like the previous ones, which is too complicated actually, but here we just have s1 squared over s2 squared, and these what we talked about. But be careful, f of 1 minus alpha, v1, v2, v1, v2, these are degree of freedom. Okay, together it's our degree of freedom. F of 1 minus alpha, v1, v2 is equal to 1 over alpha, v2, v2. These two swaps. And this becomes alpha from 1 minus alpha. We couldn't evaluate this from the table. What we do, we say it equals 1 over this one. We talked about this before in the previous chapters. And this is an example. Try to read it. And if you have any questions, let me know. And it's enough. So it's the end of this chapter. الليلة كمان بتساوي زود هي كمان تاسك زوري تيا ولا كوتاي chapter كايش exercise هي ليش هو exercise هول بن برسال كان حلكن حتى برسال زيادة حلكن باشتر باشا هل أنا فكرة كان بزن بوي دستان راد مالي آسان وطا نموني حلنا كي لها البابتك دوائن امتحان تسليتك فريانا كي calculation كان كي هول مزان شو حاسبة سرعي بكاربين باشا ديش راسك كتوبن أنا بس أبغى